So hello guys, I guess you all are doing fine. So in today's lecture we'll be doing our fourth module, fourth course I would say, for part in which we'll be doing about Google Cloud Computing Foundation. And in this we'll be talking about our what is module 9, which is what is big data. So you all must have the data, right? But what are you guys doing with it, or where you guys are storing it, or you have some collective data of your university? So what are you doing with that? So in this, the objectives of this particular module will be: we'll explore how the big data managed services in the cloud. We'll examine using Dataproc to run Hadoop, Spark, and other big technologies as a managed service in the cloud. They are basically Apache servers, okay? And we'll learn about building ETL pipelines as a managed service using Dataflow. We'll explore BigQuery as a managed data warehouse and analytics engine. So the agenda will be this. In this we'll be having the introduction, then there will be about Dataproc, then there will be two labs, then we'll build and extract, transform, and load pipelines using Dataflow. There will be two labs for Dataflow, then a BigQuery, then the lab for quick start, and a quiz and a subject. So how big is a petabyte of data? So you all must have known about terabyte. Like after GBs, like we have 128 GBs of pen drive, but after that there is terabyte, which is 1024 GB, makes 1 terabyte, and 1024 terabyte makes 1 petabyte. So a petabyte is a very large amount of data. So you can see in this a stack of floppy disk higher than 12 Empire State Building. So if there are 4 floppy disks storing petabytes, it's higher than the state building. 27 years to if you want to download 1 petabyte of data using 4G, it will take 27 years to download that. And 1 petabyte is equal to every tweet ever tweeted into 50 times. So you can imagine how much big it is. So we know that 1 petabyte is 1 million gigabytes or 1000 terabytes. But how big is that? So you can see this much big is petabyte. And how small is petabyte of data? It's only 2 micrograms of DNA. So it's very less according to our DNA. And it's very less about 1 day's worth of video uploaded to YouTube. In the YouTube on the daily purpose, there are a lot of data which is uploaded. So 1 petabyte is around 1 day's worth of video uploaded on to YouTube. So let's have the overview on big data managed services. So there are basically 3 main services: Dataproc, Dataflow, and BigQuery. Dataproc processes big data with Hadoop and Apache Spark. Dataflow analyzes the streaming data in the real time, particularly. And BigQuery modernize the data warehouse foundation. Okay. So what is Hadoop and Spark? Hadoop and Spark are basically open source technologies that are often are the foundations of big data processing. So you can say this is used as a beginner's level type. So Apache Hadoop and Apache Service are open source. Then Dataproc is managed service for Spark and Hadoop are they are cost effective, they are fast and scalable, they are open source ecosystem, they can be fully managed, they have image versioning and built-in integrations. So if you can see Dataproc in first case of log processing, what we need is large volumes of data from several sources which are aggregated each day and loaded into databases so matrices can be gathered. So imagine you have a company which gather data every day from several other sources, and you want to make a matrix so that you can find the relation or relate between that. So you want a dedicated on-premises cluster which is used to store and process the logs with MapReduce. So what we can do here is the solution, that is the cloud storage provides a low cost storage option. Firstly, we get a low storage option. Then An ephemeral data proc cluster can be created in less than 2 minutes. It can just be created in under 2 minutes. That's very much time saving. And the data is processed with existing MapReduce, which can be which is already there, and we can process the data. And it saves money and reduces complexity. In the second case, if you have a ad hoc data analysis, if you are having a company or which you want to analyze data according to the ad, so what you want to do? You want analysts are using Spark Shell but are concerned about increasing in usage, and they are unsure on how to scale their cluster which is running in standalone mode. So what they can do is they create cluster that scale for speed and mitigate failure. They can use web interface, cloud SDK, or native Spark Shell via SSH. And the value for this is it unlocks the cloud without technical complexity. Complex computations take seconds, not hours. In the third case, which is of machine learning, so what we need is Spark machine learning libraries, which are used to run classification algorithm large data set. And there is a reliance on cloud-based machines to install and customize Spark. So what we can do is Spark and mlib can be installed on any data block cluster. We can install it on any data block cluster which we want to install it. We can customize. Customization can be applied to clusters by initializing actions, and we can use cloud monitoring to monitor our workflows. With the help of Dataproc, we can do these all three things. These all three things. The value which we get is resources can focus on data, not cluster creation and management. Integration with cloud. Google Cloud unlocks new Spark features. So yes, we can do that. So what is BigQuery? So BigQuery is a fully managed data warehouse. Fully managed means that BigQuery takes care of all the underlying infrastructure. Terabytes and petabytes of data gathered from wide range of sources are stored there. It's basically a place where you can store a lot and a lot of data without any need of infrastructure, right? So what are the advantages, or you can say plus points, of BigQuery? Storage plus analytics, a place to store petabytes of data. Petabyte, which is 11,000 4K movies. A place to analyze data, machine learning, geospatial analysis, and business intelligence. They are serverless. You can use SQL queries to answer the questions. Flexible pay-as-you-go pricing model. Pay for what your query processes or use a flat rate option. Data encryption, at rest by default. You can encrypt your data stored on the disk, including the SSD and the backup media. They have the built-in machine learning. You can write ML models directly in BigQuery using SQL. So Google Data Warehouse Solutions Architecture. So here you can see there are two methods by which you can input the data: real-time data, streaming, and batch data. The real-time data you can use pub and sub, and then the batch data you can use cloud storage. Both of these things go to Dataflow and uses BigQuery. So what are the things we can do by the data which is processed by BigQuery? We can use some tools which are Looker Studio, Tableau, and Google Sheets. AI/ML tools are also there. We can use AutoML, Vertex AI Workbench. So what a BigQuery can ingest data sets from various resources. Internal data, which is data saved in BigQuery. External data that we can get from Google Cloud Storage, Google Cloud databases. Multi-cloud data, such as from AWS or Azure. And public data sets, which are already available on the Google Cloud Marketplace. So these all gets replicated, backed up, and auto-scaled. The patterns to load data in BigQuery are batch loading. We can use the batch loading system. We can like put all the data in the batch and then load it into BigQuery. Streaming loading. While streaming, we can load the data by using generated data using SQL. So the BigQuery can run analytic queries over large datasets, query terabytes in seconds, and query petabytes in minutes, which we can then use to analyze the data. So what are BigQuery ML, machine learning? So what is it capable of? The capabilities to build ML models, empowers the data analysts. In this, there is like no need to export the data, no reliance on data scientists that they will do the calculations or find out the like output for this. It can do it automatically, and it can access in number of ways using a laptop, mobile phones, or any other thing. So let's machines do the work. So what is going like in this? So the objective will be learning about machine learning, understanding the terminology used, and identify the value proposition. We'll explore about Vertex AI, Google's unified AI platform. We'll use Google APIs to apply a range of pre-trained ML models. So this will be our agenda. You can see machine learning in the cloud, building ML models with Vertex, and there will be lab, auto ML, custom training, pre-built APIs, and a lab, quiz, and a summary. So what is AI versus ML? Artificial intelligence versus machine learning. So you can see artificial intelligence is a vast variety, under which machine learning comes and under which supervised learning, unsupervised learning, and deep learning comes. So we can see artificial intelligence is an umbrella term that includes anything related to computers mimicking human intelligence. Right? We already know that artificial intelligence, right, is like a machine doing the human intelligence or human thing. What is machine learning? Machine learning is a subset of AI that mainly refers to supervised and unsupervised learning. So model training requires examples. Obviously, if you want to train a model, we need to provide it some examples. If I want you to identify myself, so you need some examples or you need my pictures to analyze that yes, this person is Ayush. So for tax filling, we need to first provide our model examples of tax filling. For the trips, you can see on the Google map, when you travel to some particular place, it shows the fastest route because it's been trained over there, because it knows and it gets the example that by using this route you can reach this location faster. So examples of trips. So how we train an ML model with examples? In the structured data, we provide structured data in which each particular model, each particular item is considered as label. In the unstructured data, we provide them with the images as inputs, and then it gets trained on with the particular examples. Then we train an ML model with examples. Like in a factory, you just have to train your robot or using machine learning about to identify the correct object or any defective object. So first you will have to tell him about all the defects that can happen in an object, and then you have to tell that model, train it on the correct object. Then when you run it, it will always check a particular item for all the defects and or for the correctness. So that's how you train an ML model with the examples. So an ML model is only good as the data used to train it. Of course, if you provide it with the good examples in a great condition, then only the output will be in the great condition. The parts should be in good condition and the parts in fractured condition. These are the parts in fractured condition. These are parts in good condition. So we can predict with a trained model. Like it's a new image. It's already a trained model. It's already trained on some examples. So it can show that it's in the good condition, not in the fractured condition. So what are standard algorithm use cases? So standard algorithms detect a pattern in an image. They predict the future of a time series and understand, transcribe human speech or text. So what is ResNet in a standard algorithm for image classification? Basically, ResNet is the already provided algorithm which is used for image classification. So what we do, we provide it with the image and the trained models divided in the class 1 or class 2. So the same algorithm applied to other data yields or a different model. Standard algorithm, trained ResNet model, standard algorithm, trained ResNet model. So you can see there are different, you know, that's all. Then the algorithm is the same, but the trained model is different. So algorithm is same, trained model trained, ideal image model trained. But you can see here it's a photo which can show that it's water lily, and here you can see it's showing fractured parts. So the barriers to entry with ML have now fallen. Now there are data availability, algorithm maturity, sophistication, hardware and software power. So these were the barrier earlier, but now they have fallen. So what are the ML options on Google Cloud? The first option is BigQuery ML, which uses SQL queries to create and execute machine learning models in BigQuery. Second is AutoML, which is a no-code solution to build ML models on Vertex AI. Custom training. You can code your own ML environment to have the control over your ML pipeline, and the pre-built APIs, which are basically leverage ML models that have already been built and trained by Google. So here's the Google AI technology in the product. In 2007, they have scikit-learning, which was there. In 2015, they got TensorFlow 1.0. 2018, AutoML, BigQuery ML was, introduced. In 2019, they were having TensorFlow 2.0 and AI platform. And in 2021, now they have Vertex AI. So what are the challenges in the ML development? So like for Gmail, Maps, Google Photos, translation, the main challenges were data, which have to be provided to train them on this, machine learning models, and the computing power. And also what other challenges were the ML tools ease of use. The tools require advanced coding skills that you already know. They takes the focus away from the model configuration, no unified workflow, and difficulties finding tools. So what was the solution? The Google came up with Vertex AI. The Vertex AI provide us with the production challenges and ease of use challenges. So the Vertex AI is a unified platform which create models, manage models, and deploy models. So what are create models? Data readiness. So the user can upload data from wherever it's stored, cloud storage, BigQuery, or a local machine. So in this, you can upload the data from wherever you want. Feature readiness is user can create features which are the process data that will be put into the model and then share them with others by using the features. Training and hyperparameters tuning. When the data is ready, users can experiment with different models and adjust hyperparameters. The deployment and model monitoring can be used as users can set up the pipeline to transform the model into production by automatically monitoring and performing continuous improvements. So Vertex AI provides us with two solutions in one. AutoML, that we don't need to code anything, it does it automatically. And custom training, we can also do it, we can also train it for our own purpose, which is obviously code-based solution. So the benefits of Vertex AI, it's seamless, scalable, sustainable, and speedy. The 4S are the benefits of Vertex AI. So then now what is AutoML? In AutoML, we know we don't need a code solution to build ML models. How we do that? The traditional ML development versus AutoML. In the traditional machine learning development, we need to repeatedly add new data and features. We already know that. We have to try different models and we need to tune the hyperparameters. But on the other hand, in automated machine learning, it automates machine learning pipelines to save data scientists from manual work. It automatically does all these three things on its own. So the data scientists don't need to do that work. So machine learning is similar to human learning. We already know what we learn is same as what we want to get a machine to learn. Transfer learning is basically building a library based on the books you want. So it's basically a build a knowledge base in the field. And what is neural architect search finds the optimal model? It's finding the correct solution or correct book we want from that particular library. That's how neural architect search is. And what is AutoML? Which is powered by the latest ML research, trains and evaluates multiple models, produces an assemble of ML models, and chooses the best one. What are the benefits of AutoML? We can train custom ML models with minimal effort, little machine learning expertise, and it allows data scientists to focus on defining business problems and evaluating the improving model research. So these are basically all the benefits by AutoML. So AutoML supports four types of data: image, tabular, text, and video. So AutoML solves different types of problems called objectives. So all the problems which are there, they all are categorized under objectives. So to start and upload your data into AutoML, we can use cloud search, BigQuery, or the local machine to upload our data, which is image, tables, text, or video, and we can put in the AutoML. To inform AutoML of the problems we want to solve, we can inform AutoML of problems to solve which may sound similar to pre-built APIs. So we can use the pre-built APIs which use pre-built ML models, or AutoML which uses custom-built ML models. So AutoML solves mixed data types and objectives, which are images, tabular, videos, and text. So we can also have mixed data types in these four categories. So what are pre-built APIs? So pre-built APIs don't require custom training data. They offer built datasets, curate datasets, and trainee datasets. So pre-built API examples are speech-to-text API, which converts audio to text for data processing; cloud natural language API, which recognizes parts of speech called entities in sentiment; cloud translation API, which converts text from one language to another; text-to-speech API, which converts text into high-quality voice audio; Vision API works with and recognizes content in static images; Video Intelligence API, which recognizes motion and action in video. So pre-built API is trained with Google datasets. Vision API, which is based on Google image datasets. Speech-to-text API, which is trained on YouTube captions. Translation API, which is used by Google Translate. So let's see the example of Vision API. You guys can just go to cloud.google.com/vision, and there you just upload an image, and it will tell what are the things or the features it sees in it. So you can see here in this picture, it can say 88% is wood, creative art is there, flooring, hardwood, wood stain, plywood, visual art, and many other things. So you guys can also try this. So cloud translation API use case. So in this we can see a Bloomberg, which is a financial software of a media company. So we can translate it. So that's all for today. So in this lecture, I hope you guys have learned all the things, and we'll be doing the labs also, and I'll be providing you with all the requirements for the labs in the next lecture. So thank you guys.